Hello. So I hit you with an exercise right away, trying to put your knowledge of pointers into practice right away. But now we're going to move on to some new applications of pointers. And I'm going to start off by talking about C strings. Now remember that C is a subset of C++. C++ came along and added some object-oriented functionality. But everything that you can do in C, you can do in C++. So I'm going to start by explaining how strings work in C because you really see how they are represented under the hood. And then we'll see how to do them in C++. Okay, so let's start with C strings. Now a string is actually just an array of chars. So I can say, for example, char star s equals hello. Okay? That's why it's called a string. It's a bunch of chars strung together in adjacent regions of memory. Okay, so let me try to compile this. So I'll say g++ out char. I called this file char.cpp. So let's say char.cpp, okay? Now it yells at us a little bit. This is a warning, not an error. It's like those little yellow caution signs you used to get in NetBeans. It says C++, ISO C++ forbids converting a string constant to char star. Okay. So it will let us do this and compile the code, but it's saying, hey, be careful because actually when you declare a character array to be equal to something called a string literal, just be aware that the string literal is stored in a region of memory called read-only memory. Okay, so I am not actually able to modify this. And if I try to modify this, so if I say, let's say s at index 0 is equal to m or something. Oops, that needs to be a char, so single quote. I'm going to run into an issue when I try to run this. Okay, so there we go, segmentation fault. Remember that? So in this case, it's because we are trying to modify a read-only region of memory. Okay. So this is called a string literal. And I can't modify that. Okay, fine. So to remind myself of that, and to make it so that I can catch this at compile time instead of runtime, I'm actually going to put the keyword const in front of char. This is like Java's final. What it's saying is this is a constant pointer. And it's pointing to something that should not change during the runtime of the program. So now see when I compile it, it doesn't warn me anymore. And if I try to change something, it won't even let me compile now. Okay, so it says assignment of read-only location. Okay, so that's all that was going on there. Okay, so this is a string literal. When you actually, in your program, say exactly what the string is going to be, it gets stored in read-only memory. Okay, so that's the first thing. Now this program isn't actually really doing anything even when I do get it to run. It's just running and it's finishing. So you can print out character arrays also using printf. So I can say printf %s, and I'll put a line break. So %s says this is going to be a character. This is going to be a placeholder for a string, for an array of characters. And so now when I go to run this, I'll see it prints out hello. Okay, so that was a bit of a roundabout way of going and printing out hello, but it shows you how strings are represented in C. Now some of you may be scratching your heads and saying, well, how would printf know when we reach the end of the string? Because remember, in C and C++, we don't store the length of arrays. So this is an array of characters, of chars. But how do I know what the length is? Okay, so let's investigate this a little bit. What I'm going to do, actually, is I'm going to print out each character on its own line in a loop. So I have some prior knowledge here, and I know that hello is 5 characters. So what I'll do is I'll just say for int I equals 0, I is less than 5, I plus plus. And I'll say printf, And for a character, it's %C. That's the placeholder. And I'll do s at index I. Okay, so this is just to demonstrate that this really is an array of characters, of chars. If I run it, okay, cool, I see each one. But what if I go beyond the end here? So what if I loop up to 6? Will I get a segmentation fault? So no, actually, I get this blank. Is that a space? What is that? So we actually have to look a little more carefully to see what's really going on here. So I'm going to keep going one past the end, but instead of printing them out as chars, I'm going to print them out as ints, actually. So you can cast a char to an int. Okay. So a char is actually a 1 byte number, whole number, turns out, behind the scenes. So let's just see what this prints out, and then I'll explain a little more what I mean. Okay, so now this prints out a bunch of numbers: 72, 101, 108, 108, 111, 0. Okay, so to see what's really going on here, I have to go to look at something called an ASCII table. And so really what's happening is a char in memory is represented as a number. As I said, the char is just whole numbers, and there's 1 byte of them. So let's look up and see. So I've gone to this ASCII table here. And let's look up and see, well, what's the number 72? Okay, so there we go. That's the capital H, right? Okay, what about 101? So 101 is the lowercase e. 108, I can see it here. That is the small l. So I have capital H, lowercase e, l, l. 111 then is lowercase o. And what's this 0? What is 0? Let's scroll all the way up. So something called null. Okay. So this is what's known as the null terminator. And so every character array in C and C++ actually ends with the null terminator by convention. So I know it looks like there's only 5 characters here, but there's actually 6. And the 6th character is the placeholder that lets me know how long the string is. Okay. So I'm going to have you in an exercise write a method to determine how long a string is, just by looking to find the null terminator. So you could just cast it to an int and say is equal to 0, but actually let me do something else. I'll just say, I guess what I'll do is I'll print right next to this a Boolean. So by the way, Booleans in C++ is bool. So I'll say bool is null equals false. And I'll say if s at index I is the null terminator. So here's it's an escape character actually. It's \0. That's how you write it as a char. Then I'll say is null equals true. So okay, so let me just do that. So what'll happen here is it'll print the number that the character is, and then it'll print true if it happens to be the null terminator. So let's run this real quick. Oh, maybe that's not for Boolean. Hang on a second. Okay, I can actually just print the Boolean as an int. So let me cast that as an int. So casting works the same way in C++ as you see. Okay, so I see none of these are the null terminator, but when I get to the end, that's the null terminator. Okay, cool. So yeah, let's have you quickly do an exercise where you write a method to figure out how long a string is.